Hey, welcome back to the lecture. So I have now connected my USB logic analyzer to PC9 pin of the Discovery Development Board. And now let's measure the clock. So we have already downloaded the code, right? So now the code must be running on the board. So I'll just hit the reset button of my board and I'll just go to my logic analyzer and I capture. Great, here it is. I'm getting the clock and it is saying that yes, it's 4 megahertz. Here it is, it's showing 4 megahertz, isn't it? So you may have to sometime set the sampling rate properly. So if you are measuring 4 megahertz, then you may have to keep the sampling rate twice of that. So let's see whether I would be able to measure it at 8 million samples per second. So I'll just try once again. So here you can see still I am able to measure it. So 4 megahertz, that means the clock is 4 megahertz, right? So that proves that this output is 4 megahertz, right? So that means 4 into 4, that is 16. So that means this clock is indeed running at 16 megahertz and H clock is at 8. So now what I do is I'll just change this prescaler to, let's say, 2. So that means I should see 8 megahertz. So when you make changes to your project, don't do anything, just go to project and click on generate code. It will rewrite your code. Now don't click on open project because project is already open. Just click close and open your keel. That is this one. And now keel will say that something is modified. That's true, right? Because we changed something in the CubeMX, right? So click yes, yes, yes. So now the code is updated. So now just rebuild your code. So the code has rebuilt and now let's download the code and let's go to our analyzer and let's just reset your board. You know, the code is running and let's adjust the sample rate because we are now measuring more than 4 megahertz. Actually we are measuring now 8 megahertz, right? So let's increase the sample rate to, let's say, 16 and let's capture the output. And here you can see now it is showing 8 megahertz. So now again, if you go to here and if you make this as 1, you should measure 16. Let's see whether we can able to measure 16 on our analyzer or not, because my analyzer gives problem when I try to measure higher frequencies. So let's try that. So now let me again go and regenerate the code. I just made this as 1 and generate code and go to your Eclipse project. Yes. Alright, so now let's download the code and go to my analyzer, and this time I'll just make it 24 million samples per second. Alright, I'll just do it this as just 2 seconds. Start. Now my analyzer is not, I have to reset my board, sorry. Now let's capture and no, my analyzer gave up. It cannot measure 16 megahertz. So there's a limitation. So but if you buy some high frequency USB logic analyzers, then you should be able to measure it, because mine is an older hardware and I can only select 24. That's okay, it's a limitation of my analyzer, but it is actually producing 16 megahertz. Great guys, so that's the introduction for you to the clocking system of the microcontroller, and we will again come back to this while understanding the codes and all by writing our own code to configure the HSI, HSC and PLL as you make a progress in the codes. So but this is just an introduction to the clocking system. All right, great. So now I will meet you in the next lecture with another interesting topic.